A lot of you, I think, today is here for this What's New session, so we're going to have an hour and a half of What's New. Like Quentin says, this is very early. This has just been released worldwide, the What's New data files, all of that. The release that we are working on is SOLIDWORKS 2026 PR1, so it's pre-release 1. There'll be a pre-release 2, and then the GA, the general availability. We expect that about in 3 weeks, kind of Service Pack 0, will start becoming available to you as customers as well. Just one thing, if you download, because sometimes people are signed up for beta, if you download the 2026 PR1, do not install it into your commercial environment, please. If you do, contact us, roll it back. Okay, not where we want you to use it yet. So, my name is Edyss Scott, and I'm assisted here with Leon Bielefeld in the driving seat behind the computer. Any mistakes, I'm going to blame him, and he's going to owe me. So, I'm the technical manager for MECAD. I've been with the company 18 years, been right through the company, right from the bottom up. So, Leon joined us a few years ago in the Centurion team, and he's our team lead of the technical team in Centurion. So yeah, we're going to take you for the next hour and a half. The data set that's applied worldwide for the What's New is the Vermeer company. And you can see there's a bunch of agricultural equipment. They do a lot of other mining equipment as well. And I just want to show you a little video, some interesting points, but just a bit of history on Vermeer, the journey with SOLIDWORKS, and just putting the data set that we are looking at into context as well.
Vermeer is a grassroots company of local people, some of the best engineers I know, and they use SOLIDWORKS.
When it first came out, it was much easier to use than other solid modeling type packages. I think it continues to be that way. The menus are intuitive, easy to understand. You don't have to be that expert user to take advantage of a lot of its features. If you are that expert user, it has those, but you can operate at that entry-level user and do really well. It's important to have a package that you can be efficient at with minimal training and minimal seat time on the model.
One of the machines that we use SOLIDWORKS to design is our medium drill. The medium drill is used to put in utility cables for phone lines, electrical lines, fiber optics throughout the world. It is a very complex machine with a lot of hydraulics and electrical on board. A lot of features to help the drillers make good decisions, whether it's water or sewer lines. And we use SOLIDWORKS for the entirety of that design. There's no other CAD for mechanical design here at Vermeer.
There's so many other little parts of the SOLIDWORKS that we integrate with as far as doing structural analysis. Being able to do multiple configurations, I think, is nice. Weight was a big issue for us. We had to maintain a certain max weight. You had the weight distribution on the semi-trailer versus the tires, and we had to move the center of gravity around.
It's so fun to be able to show a concept to someone who's not in front of SOLIDWORKS every day to try to explain to them maybe how a part fits together. You can quickly show them any of those parts. You can show them the inside of the part, you can show them the back side, you can rotate around a little bit, you can communicate faster and get on the same page.
One of the advantages of working with SOLIDWORKS is our ability to reuse components throughout many different models of drills. And many of those components can be reused from one drill to another. Take an idea from one drill, size up the geometry with SOLIDWORKS' parametric modeling, it speeds up your process, but you change the part once, and it propagates that change throughout the assembly models that part is used in.
When we make these changes, we reduce design cycle times, which reduces cost, and we improve quality. So it's kind of a cheaper, faster, better all at the same time.
When I started, Vermeer was significantly smaller. SOLIDWORKS continued to grow with us and allowed us to do the things that we needed to do that our customers and our team members have been asking for. I would say SOLIDWORKS is one of the reasons why we picked the next move.
We wanted a platform that worked on the cloud. Then we wanted to be able to integrate different business units and be able to replicate those processes globally. The 3D Experience platform provided that level of functionality that we needed to grow as a company and continue to get more efficient in those processes.
It's a very versatile, useful software that doesn't restrict us, just a matter of your imagination, what you can come up with.
In July of 2018, we had a EF3 tornado.
This one didn't stop. This one actually did hit. So we lost, I'm going to say, a third of our manufacturing square footage.
And our goal was to actually get back up into production. Part of that was to find different manufacturing locations throughout the area.
We were scattered out and about, and we were still able to function.
We were back up into full production in 60 days.
The year of the tornado, we had a record year. The backbone that we put in to run SolidWorks, we were able to run it at any location.
The partnership with SolidWorks and Dassault Systems continues to grow. We would not be the company we are today without SolidWorks. It is used for 100% of all our mechanical CAD design, and we use it worldwide.
Over the next 10 to 15 years, I expect the Vermeer SolidWorks relationship to continue to grow, to solve the new problems, to leverage the new technology. The next generation can come and see the work of the past, and then we can keep absorbing and growing our knowledge base as a company.
Okay. There's a few things in this video that stood out for me, apart from the tools and the things typically that they use. I think all of you that's sitting here, your companies are often based on your CAD design. That's the IP that Juan Paulo spoke about as well. That drives your organization, it's your livelihood. You guys are the heart of the companies, being engineers. And all those guys actually in the video look familiar. There's even a few guys that look, if you can be family of some of them. But yes, worldwide, we're all engineers and we face the same kind of things. The part of that tornado that hit, where, a calamity. And this company had to get back up, and they were up to full production capacity in 60 days. Partnering with, obviously, all their suppliers, but the backbone, like they say, with the SolidWorks systems that they've put in place, and the assistance with their resellers to get their data, share their data, guys jumping in and connecting them up, getting them running on computers again, was essential for this company. Because this is, if we don't have information, if we don't have data, our companies cannot actually produce money. But the one thing there that stood out for me, in that year of the calamity, and that's, for me, a trait of us in South Africa, they had actually one of their best years. And that's what I've seen with a lot of South African companies. In the difficult times, you guys stand up and you really perform. And that's where we want to partner. From MECAD's perspective, be alongside. We've had it with a number of companies. We luckily don't have tornadoes, but we've had guys with server rooms burning down, servers, and then the backup server was in the next blade just above it, and they lost all their data. We could jump in, we could start getting data from caches out of computers, rebuilding data sets, and building years of data back within a few days, and get that company running again. So that, I want to say, when, what's the saying? When the going gets tough, the tough gets going. Freek spoke about it, about our core values, who we are as MECAD, and that's what we want to be for you guys as well. So when the tough gets going, let's get going together. So, okay, let's jump in. That's my speech for the day. So, SolidWorks 2026. We're going to look at the release cycle last year. Those of you, there's a few guys that I've seen that a number of you guys recognize me from last year. They said I must do better than last year. No, one of the guys said he really enjoyed last year, so thank you for that. Leon, you can show us the next slide of the release cycle. So last year we explained to you that 2025, the GA, that's the Service Pack 0, General Availability. So there's a little bit of new terminology coming in. I explained to you the FD, which stands for Functional Delivery. Okay. We showed you last year in the What's New of 2025 that some of the things was already released in some of the service packs of 2024. Okay. We see the same thing this year. So 200 plus enhancements in 2025 Service Pack 0, GA. But then through the year, FD01, 124, 96, 74, if you count that up, that's more than 300 enhancements that's been pushed out through the year. That's different to the past, where service packs would just fix issues, okay? And then all the improvements gets launched with Service Pack 0. And then only it goes into the market, and then you figure out what's not working, and we have to release Service Pack 0.1 immediately. With this philosophy of continuously releasing enhancements, what we find is we got a more stable release cycle, and you'll see now, because there's been such a lot of functionality released in 2025, that 2026 is releasing 111 only, nearly half of last year. But we're going to get Service Pack 1, Service Pack 2, we're going to get more enhancements. Okay. We're going to show you stuff as well today that already was released in 2025. So if you're working on 2025 on a service pack, we're going to show you things from FD1 and FD2. So if you're on the current latest one, you already have that functionality. Okay. We are limited for time. We are going to have to pick the things that we show you. We want to leave you with some functional thing. So what's new 2026? Let's look at everything that's there. There's a massive list. We're not going to be able to get through it. What we are going to do, because as Quentin explained, we're the first in the world to show this to you as well. This was only shown to us last week. And we are going to do focus areas on the individual ones of those headings that we'll make available as well to share this information. Okay. And we're going to continuously do that with the releases. So we're going to change the way as well that we communicate these enhancements. But we're going to jump into parts and look at some things that will benefit you. So in parts, we cover sheet metal and structural systems as well. So some base flanges. There's an offset that we can do of the sketch that we're going to show you live in SOLIDWORKS. We're going to look at break corners and enhancement with a filter for internal corners. And then deleting equations. In the past, if you've got a sketch with equations and you delete the sketch, then everything goes dangling because they're still sitting in your equation manager and it's errors and you have to go and find them. That's been improved significantly. Structured systems, a lot like weldments. We call it weldments on steroids. It's been developed over the last 5 years alongside, in parallel to weldments. Please start looking at that. Otherwise, contact us and look at this, the advantages of using structured systems. You'll see now, we're going to open this model. It's a lot the same, but it's much easier. It requires far less geometry, like 3D sketches and things like that, to generate your systems. Much quicker. And the guys with a non-subscription, Solid Professor, will explain everything to you. Brilliant, yeah. Remember, Solid Professor is micro-learning. That's the name of the game. Rather than micro-learning all the ridiculous stuff on Facebook, do your micro-learning in Solid Professor. And then we're just going to look at cutlass properties that's been enhanced, reference points, and the last thing we'll talk about in parts is bounding boxes. So the bounding boxes and the custom properties and the cutlass properties, for those, it becomes more and more important now for you not just to generate your CAD and have a very nice 3D model, see interferences, do simulation. It's enriching your CAD data. So there's a number of faces here that I recognize that work with PDM. And you guys are concerned about the metadata that goes with the part. And you want to automate that information, push it down into your ERP, PLM systems. You want to drive your CRM, your manufacturing. And that is that rich data that goes with your part. Okay. So there's continuous enhancements. And I tell you, in the last 5 years in South Africa, there's so many companies that suddenly, manufacturing companies, that suddenly rolling out ERP systems, PLM systems. And it is of the utmost importance to have accurate files with accurate data that you can push into those systems. Okay. We're going to speak more about accurate data, especially around AI as well. So we're going to jump into SolidWorks. Leon has got this. This is the cabin of that Navigator mini drill that you saw that they've got there. That drill can drill like 1.6 kilometers with the pipes that they connect, horizontal, and control where it's going to go under buildings and under paved roads and things like that. I've seen similar machines in South Africa as well. Okay, so if you look down there, there's a pink sketch. We changed the color so that you can see it. In the past, if you want to do a base flange, your sketch have to be where you want to create the flange. Now, in base flange, it looks exactly like we have in the normal extrude function, where we can pick the offset option. So Leon will show that. He's going to pick offset, and then he's going to offset from that sketch upwards with increments. Okay, so I can put in a value, and I can say at what height it must be. Or I can rather pick a vertex anywhere in my model, and it will take that sketch, and horizontal to that, it will actually create the base flange at that point. We want that flange to sit on top of a member on a face, and that will then automatically adjust if anything moves as well. So he's going to pick the top face and create that. Okay. Now sketching sketch bend. That's not an enhancement, sketch bend. If you think that's an enhancement, then please come on training immediately. Okay, that's been there forever. Okay, and then what we want to do is break some corners. So if we use the normal break corner tool, you will see if we zoom in there, there's an option now in 2026 that says internal corners only. Okay, we're going to activate that. Use the normal collect all bends option. And you'll see if you zoom in, it's only picking the internal corners. Okay. So just to show you the functionality of that, if I disable that tick in the situation where we are now, we've already said collect all, it will automatically now take all the external corners as well. That's something that's been requested by a lot of customers to just select the internal corners. Because in the past, if you want to do that, then you have to go and do it one by one. Okay. Small thing, but it makes a massive, massive change. Okay. We're going to look at that sketch. And if Leon is going to show us there's some equations in that sketch. And like I said earlier, there was quite a few nods here. Yeah, if you delete it, then it's warnings and things, and I have to go to my equation manager and go and clear them up. Now, if we delete that sketch, normal delete that we do, and it's the normal confirm delete manager that comes up. Leon is going to zoom in for us, and there's a new option that says delete equations. And when I activate that, it's actually going to list the equations that will be removed out of my model as well. Nice thing about that, if I hit OK, they're gone, no warnings, nothing to go and solve. Okay, that just makes working with equations, it takes that annoyance factor away from that. Okay, just if we look at that top corner, we'll see that the frame is interfering with the sheet metal cover. Leon is going to navigate to the actual system there. That's created not with a weldment, but with a structured system. There's quite a few complex corners in here. So you'll recognize a lot of the functionality from weldments. Leon is going to edit the existing feature. And then it's got options where it gives you different corners, and it says the complex corners. And then we're just going to go through the options of where members are meeting until we find the one that we want to edit. He's going to right-click on the corner and then say zoom to selection. So right from there, it's going to take you to the graphic and zoom. And then that little blue dot, when I click that, it brings up this selection manager. And this is part of the AI that Juan Paulo referred to as well. Selection assistance that's happening and improved. So in this preview, it's very easy to see the options. And Leon is going to go through until he finds the best suited one. Is that the one we want? You can see perfectly trimmed for us. Okay. While we are here, this is We will have a cut list in this because we've got different members. And we know that in the cut list, we can go into properties, and we've got things like length, total length, all kinds of things, the description of the different members. Now, a lot of people want to bring this information into my custom property, into my parts, so that I can pull it onto my data cards and PDM. I want to bring it into my BOM and list it maybe in an annotation in my drawing. And you have to do a lot of nifty footwork to get it into the custom properties. Now, if we go to custom properties, it's available on the drop-down as any of the other properties. See, Leon will go to cut list properties at the bottom, and then he can pick any of the members' properties and build it up in our custom properties. So that's, I think, a significant enhancement for automating. Remember I said the accuracy of that information, that enriched information that we want to pull through into our ERP for costing and quoting and all those kind of things. Okay, Leon is going to switch back to the assembly. And remember, he's using the tab, Shift tab, to hide components. Just hovering over it, hitting tab, and then Shift tab will bring it back. With that, he's going to drill in until he gets to, he's navigating to a sub-assembly. So just a reminder again, this was one of the tips and tricks and the things last year, is the breadcrumbs. So if you click there, the breadcrumbs come up, and then that will allow you to easily navigate and find and open the level that you want to. We're going to open the sub-assembly of that. That's actually the air conditioning unit for the cab. So that's the air conditioning pipes. Who was asking me? Quibus. That you're using, or telling me that you're using 3D sketches significantly. And now, in reference points creation, that can be very powerful in creating and driving 3D sketches. In the past, it was quite difficult to build these points, and you have to read it in the table. Now, in a reference point, it's part of our normal reference geometry. It's been there always. Okay? At the bottom, they've added the functionality to define a point by adding in the values. Now, we'll see if Leon is going to remember his values correctly. What is that? 28.3, 17.9, 21.7. That's correct, Leon. Well done. So that's going to add another point, and then you'll see we're going to show you a 3D sketch that's driven through points, and that positions our pipe with its bend. We know where it needs to go in space in our assembly. We can get that information, and we can easily drive that, and then we're just going to use that as a path for a sweep. So while we're here, we're going to use this as an example to show you bounding boxes. But bounding boxes had a bit of a flaw. So I can use, if we see there's a bunch of options to orientate my bounding box. I can use a custom plane that will orientate it. But if the part shape changes significantly, because what I want to reference my bounding box length and width and thickness. Now I change my dimensions, and then it decides, okay, now this thing is longer than what is wide, and it swaps it around, and it just kills my information downstream again. Okay. So what's been introduced in 2026 is the option of the coordinate system, but then on top of that, I can fix the direction. So Leon is just going to select the X, Y, and Z of the coordinate system, and you'll see he's now specifying that length is equal to my Z-axis, width is X, and the thickness is defined by the Y. Sorry, Z, X, and Y. Okay. The nice thing about that, it fixes the bounding box exactly as what we liked it to show. It sits in my tree, and you see there, it gives me all the information about that bounding box. Okay, again, this is becoming more and more important because I want to specify, especially for manufactured parts like milling parts, I want to be able to specify a stock. Because again, my ERP needs to take that into account when I do my costing for the raw material. And we can utilize bounding boxes for that significantly. We've shown with one of our customers that, and we compared it to similar software, and we did the same parts, modeling the same parts for a very well-known security gate company, choosing software, and we showed by using the mouse gestures, the shortcut keys, working in your screen, especially these days. We're working with more monitors, bigger monitors, 4K. Your travel times becomes excessive. But working with the enhancements of the, as I say, the HUD, in-our-face display of commands, we were 30% faster in designing the same parts. And that was actually not done by us, it was done by the customer themselves independently. So those kind of things do make a difference. Okay, we're just going to quickly change this part to a different configuration where we chop and change the size of it. In the past, this would have caused the length and the width to swing around, but now we'll see that it adjusts accordingly. Looking back at some of the things that was in 2025, we just picked two quick ones to show you. What we want to show you, Leon has got a little part there. He's going to jump back into SolidWorks. We're going to sketch squares and then drive an edge flange with vertexes. So this has been released. The vertex has been released. It was actually in the previous slide. Leon, you can open it so long and park there. In FD1. Sketch the edge flange enhancement, FD1. So if you had Service Pack 1 of 2025, you would already be able to do this. And then in Service Pack 2 of 2025, sketch squares was introduced. Okay, let's quickly show you what they are. Okay, we want to create a reference sketch on my top plane that's going to drive my edge flange length around there. It's a square. We've all created squares. We only got a rectangle tool, right? So we're going to use a rectangle with the center lines to the midpoints. Remember that option, midpoints and corners, where they go diagonal versus square. That's been around for a while. Now, rectangle tool, center rectangle. If you hold in Shift, it automatically becomes a square. Okay. Quick and easy. And if I select that, SolidWorks makes it equal. And now if I add one dimension, I've got a square. So the next thing that we're going to do is we're going to add some edge flanges here. Leon is just going to add a normal edge flange on every little lip of that. Just a blind edge flange, and then when they're all there, he's going to select the new option to take it up to vertex, and then he's going to pick one of this center point vertexes there. That will connect my edge flange to my reference sketch. And now that will allow me, if I go into my reference sketch in the tree, then with instant 3D, I can actually grab that and I can drag it, and dynamically you'll see my flanges update. Just to show you some of the other enhancements, we're not going to go and say look back. There'll be notes 2025, so these things have been there. Assemblies. This is a sub-assembly. It's the boring head that's controlling the boring pipes of the navigator. And we're just going to look at a cosmetic change indicator that will avoid assemblies to force you to save. Okay, that's been quite a pain. You've done an assembly, now you want to go and look at a part, you want to measure something, do something, and then you have to go and save a massive assembly. Okay, and you change nothing. Okay, massive change. It's driven. Why it's there? It's because of cloud becoming the norm. Saving our data to the cloud. We don't want to continuously save. We want to limit that. But we're getting that benefit right in our normal SolidWorks as well. Table displays, so for configurations and for display states, when they brought in tables a number of years ago, it's probably, Rudolf, can you remember, 6, 7 years ago, they brought that in, maybe even longer. That's changed the way that you manage your configurations and your displays. That's made it a million times easier to use it. But that's been enhanced. And then fastener automation, there's some of the AI. That's what Gianpaolo showed you in a video. We're going to do it live for you, just to show you it's not just his marketing. And we'll explain that as we go. So if we go into this assembly in SOLIDWORKS, Leon is just going to open that for us. What we want to do now, as I say, this assembly is done. So Leon, you can open that part and then tile them next to one another. Okay, the assembly to the left. That's it. Okay, now you can just zoom in on the assembly name on the top there. Okay. So you will be used to it, maybe it's in your reflexes. That name, as we see it there, we know it's saved. How do we know? Okay. How do we know that the assembly need to be changed? Saved, sorry. That's a little asterisk star. Good for you. Let's see if I can do it again. Hey, I must go and play frisbee. There'll be a little asterisk. So we're used to it in normal Windows environment as well. As soon as a file needs to change, there's a little asterisk telling you, look, this file is unsaved. Now, we're doing this very deliberate to show the effect. We are going to, in the part, just create a reference plane. Remember, control drag of a standard plane opens up the create plane. Again, that's not an enhancement, that's been there for 10 years or longer. And immediately, when I made that change, it's not just the asterisk now. It's square brackets with the asterisk. So it tells you that something in the assembly, one of the parts, has changed. You will have to save that part, but you don't have to save the assembly. Okay. So it's an indication that there's a cosmetic change somewhere. We're going to try and show you to the best of our ability what we can do and how the software actually analyzes and figure out, did anything change geometry-wise, fit, form, or function that require the entire assembly to change? So did anything in my part change that will affect positions in my assembly? So we can hide that plane. We can delete that plane. We're going to look at the sketch that's over there. We're going to resize that sketch. But that sketch is not used to drive geometry in my part at the moment. So I just want to play around and see, will it fit? Things like that. I'm not going to ask Leon to zoom in every time, but those brackets stay there. Okay. And we're going to add a decal to our part. Okay. None of those things actually makes a change to the assembly. The assembly doesn't really care. Parts are going to save, it's going to be there, but I don't have to save my entire assembly. Okay. Even if I go and edit some of my components in context of the assembly. Okay? Again, I'm going to take a part in my assembly, I'm going to change the color. It's not that difficult, it's only the color. Leon is going to make it a blue color. If I don't tell him to make it blue, he's going to make it pink again. That's a cosmetic change. But now he's actually going to go in and edit a feature of that part, that extrude that created that, and is going to fiddle around with the size of that part. Now that obviously is changing geometry and forcing my assembly. But I've played around with it and I decided, no, I'm not going to do it. So I don't apply the feature, I kill the feature. Okay? And still the assembly will say, I'm not bothered. Okay. So just to show you all the things I can do in parts and to the extent of what it's intelligent enough to see, okay, nothing changed that concerns me. I don't need to save. It's a massive, actually, if you go and think every time that you fiddled with a part and you have to click save, maybe it's 5 minutes that you wait if it's a massive assembly. Now you can go and do a lot of those things. It will warn you, but you know it's just cosmetic changes. Okay, massive difference for working with assemblies. We're going to look at the tables next. So remember, the tables has been introduced a while back. So this is display states. Display states, as Leon is toggling through them, showing the left side, showing the right side, is still one of the most efficient ways of showing assemblies in different ways without using configurations, okay? Because we're just hiding components. In the past, it was, how many times I confused myself. I have to go in, change it, then create a display state, and then update it, and then I was confused. But when they brought in the table shows me, remember, it's just a view, and it shows me what components are hidden in each display state. Okay, but there was a few issues there because there's a whole bunch of information per part that's shown, and it was very cluttered. You can see it's squashed up, and it was difficult to work with. Okay, now in 2026, it's just a bit of housekeeping, making it much easier to use. I can resize the columns. Firstly, you expect those kind of things, but it's not necessarily always available in the software. But now I can resize it, I can order this, I can have the additional information on a per part level with a drop down, and I can show the different options. Just zoom in there, Leon. So it will show that part, it will show the information of the reference display state and where it's hidden or not. I can control it by ticking it on or off, and that will control the visibility of that part in the display state. So the table is a very useful tool of managing my display states. Okay, we're just going to set something there, that bottom part of that foot, we're going to make that all black. That's not referring to the rugby team. We've beaten them, we sorted them out. So we were very happy with that. And we also just going to look at the configuration here. Configurations as well has got a table. I can view an inner table. I can set up that view by adding parts to that table. And typically what it shows me is if a component is suppressed or unsuppressed. But in the past, when I added a component, it showed 3 sets of information. How do I add a component or a subassembly? I'm double-clicking it in my screen, and it's adding it into my view. I can see it is not ticked to be suppressed. Okay? I can tick it and suppress it, but what we want to show you is on the drop-down, the different information of the configuration of the component, as well as if that component is fixed or floating, if it's a subassembly. That was always what default was there in your face, and this thing was very cluttered. So it was not really, it was working on the part level, but it was nearly impossible to work with it in assemblies. But now you can see those different fields. I can delete them or untick them and remove them, and I can set it up to see the information that I want. And again, on a per part or per sub-assembly level. Remember, that view can be saved. Again, that view is just showing me what's happening to those parts in my configurations. It's not actually driving my configuration, but I can use it to manage my configurations. Okay. Very nice, powerful way of visualizing it and seeing it, because in the past, display states and configurations, I will have to go and activate it, look at it, make changes, then go back to the other one and see, oh no, I missed it, was wrong. Yeah, I can see it in one environment. Okay, cool. So now we're going to show you some magic. That's the AI. So fasteners, you don't have toolbox, you've got a custom library in your company. We've got, I spoke to somebody earlier that said that's what they do, that you generate your parts out of toolbox, you remove all the toolbox flags, you put it in a library, and you make it available to everybody in the company. So that part's got no intelligence, it's got no reference mates, nothing like that. So these bolts in this file here, none of them are toolbox items, but we're going to drag a washer, and as Jean-Paulo said, the AI is going to say, this thing looks like a washer. Let's let it behave like a washer. So when Leon drags it, I don't have to go and put it concentric, flat. It's just going to pop in. Did you see him do the washer and the nut? He's going to do it in a different area as well. We're just going to open that bolt. Oh, there he's dragging the washer already. So let's just quickly look at the actual bolt. And if you look at the tree, it's just a normal SOLIDWORKS model. No reference mates. In the past, if you wanted to do that, we taught you to go and create reference mates, that if you drag it in, it will snap. Not required. AI says, hey, this thing looks like a bolt. So if I drag it, it's going to behave like a bolt. Like Jean-Paul said, they're starting with this with fasteners, and they want to take it to every single component, where it will actually learn and say, typically, if something looks like this, it's going to make like that. So we're not going to create mates like what we used to. Yes? So it's created the concentric mate, and it's created the coincident mate to sit down on the face. So for every fastener we put in, we do those two. Concentric in the hole, put it in the mate. Actually, those last washers, Leon, that washer, just add the bolt on there as well. Okay. That's actually a slot. That's not a hole. Leon, let's just check. Yeah, the bolt used the washer, but the washer, when I dragged the washer over, said, oh, it was mated to a slot there. I'm going to do the same here. Yeah, it used the concentric mate in one of the edges. Yeah, so it's quite intelligent, and this is, AI. We're not seeing the AI. There's no AI button, but there's AI already in the background happening. Okay. The last thing we're going to add, so from our library, again, just a SOLIDWORKS part. So now we're going to add the part from our library effectively by dragging it in, and you're going to see it snapping into those holes with the same thing, creating those mates for us. Okay. Remember, that's what Jean-Paul said. They're striving to change assemblies, that the assemblies become fun to make, dragging it in, putting it together, and just making it a lot more efficient. Let's jump into drawings. This is also what was shown earlier, the auto-generate drawings. This is, you'll see it also in 2025, FD01, and then further improved in FD03. This do require that you have cloud services, okay, for the auto-generated drawing. So anybody that bought the license since June 2023, you've got the cloud services as part of your subscription, because you need to connect to the platform to get access to this AI engine. It runs in your normal SOLIDWORKS. It's just the AI engine that gives the intelligence in the background to generate the drawings, runs from the platform. Okay? We'll help you set that up, but this is exciting development. Creating drawings, I think all of you will agree, I spoke about it last year as well. I think we all spent more than 50% of our time reverse engineering our 3D parts back to 2D to communicate, to have it manufactured. So what she's asking is, will it also jump? So remember, that's a function of Toolbox where it will automatically adjust to the hole size. But a lot of companies don't use that. They download and create specific bolts with fixed sizes. So if I want a M3, I take a M3. If I've got a M10, I take a M10 because of my metadata. So my part number, my supplier, all those kind of things are filled in. So a lot of companies don't use that type of automation because they want to very strictly control that information. So no, it will not adjust to the sizes. It's built for the parts that don't have that intelligence. Look, it uses Hole Wizard here to identify that as well. So it brings that into the AI environment, yes. This is going to be enhanced. This is beta version. You'll see there's drawings when we run it in SOLIDWORKS, it's going to say this is in beta. There's a massive amount of enhancement going in the background into this. Okay. So auto-generate drawings, we're going to look at magnetic lines, been around, but now we can do annotations and geometric tolerances as well. Break dimension lines. We could break dimension lines before. It's been enhanced again. And it now goes when it overlaps over text, you can break it as well. We can add custom text in geometric tolerances. It was a pain in the past. If I added geometric tolerance and now I want to put additional information, I had to go and create a note, and then you move the geometric tolerance, and the note doesn't go with, and then that's random information in my drawing. I don't know what's going on. Okay, so nice announcement. I see quite a few nods of heads of people who that happened to. And then surface finish indicators updated for ISO 21920. Okay, Leon, let's jump into SolidWorks. Good. So I want you to look closely. We're going to pre-select a few things. So we're going to take top of the tree, my assembly, that whole sub-assembly there. Then we're also going to select 2 other parts, individual parts in that assembly. And we're going to go and select the auto-generate drawing icon on my pop-up. Okay, go and look for that. Add it in 2025, FD1, FD3. You can change the title of the drawing. You can change the save location. We're just going to run it in default. And as soon as you run it, it opens a palette on the side, and it shows you how it's actually generating this in the background. Good. This is going to take about 30 seconds. And then it's going to create these drawings. And earlier on, John Paul has said this do a lot of the initial work of creating the drawing. It's not going to be perfect. If you want perfect, you're going to use the tool that Andrew is going to show you after lunch. His tool's perfect. Where's Andrew? There's the man. Okay. We built our own tool that runs and create drawings with a lot of success, but there's definitely a lot of innovation in the AI side of this. So last one you can see there on a little green indicator. It's nearly there with the last drawing. And then it gives me a link to open that drawing. Okay. I didn't touch it. I just selected the parts and say, go. Okay. That's a drawing created. You'll see there a bunch of views. I have to do a bit of cleanup. That's where Andrew's intelligence comes in, where his stuff is much neater. But here, it even created, it analyzed the part, the AI engine, and it analyzed and says typically people will put in a section view there. And I can delete views that I don't want. I can go and reorder. Leon, let's look at one of the other drawings, the other part drawing. Okay, another part drawing. You don't have to clean this one up. Much of the same. Go to the assembly drawing.
Sorry, is it possible to have this set up on your own company's template, or will this only be able to work on SolidWorks template?
No. That will definitely be on your own company template. So there will be some pre-setup where you'll load your templates. Yeah.
Oh, okay, fantastic.
Yeah. Again, it's something that we're willing to work with you and test with you. Just remember that you do require cloud services. If you're not sure if you have it, speak to one of the sales team. You should have your territory manager that you can speak to. You should know them all, BDE or the ISA, and they can verify for you. Okay, so Leon has cleaned up that drawing, but you can see within, we spent just more than a minute. We created an assembly drawing and 2 part drawings in that time. Okay, there's no way that you're going to do that manually, and that's going to take you 10 minutes. A lot of these changes are driving, and we're just going to see more and more and more of this. Just magnetic lines on this one. It's been around. I can use a magnetic line for balloons, but I couldn't pick up geometric tolerances and annotations, so Leon is dragging it. It's picking it up with a magnet, jumping to it. He's going to drag one, add it, reorder it. And you see when I click on any of the items, the magnetic line becomes visible, and I can adjust it, and when I click it, it's gone again. Okay. Very powerful tool. It comes from Composer, brought into SolidWorks. Let's look at the break dimension lines. Who knows how, if I've got dimensions with lines crossing one another, how do I break a line of one dimension to have a gap when it goes over the other one?
When you click on a dimension, it will open the menu on the side, then you go down, there is a where you...
Okay, excellent. Okay, let's quickly look. Like he says, we go to a dimension, we right-click on it, and then one of the options will be break dimension line, add dimension break. So that's been around for a long time, but this has been enhanced. If I pick specific lines, it will break over. Yes? Is there another question? Yes?
Early on, we were shown the AI-assisted sheet metal tool where you could put materials of the same thickness and it grouped them on a big sheet to cut out.
That's Freak's tool.
Yeah.
Yes.
And the question was, have we got a feature that calculates the waste. So we're always concerned with the part and the assembly, but what about the waste? As soon as you put it in, it's now potentially able to do that as well.
So because that tool of Free can actually nest the components in well, I can actually start working on a wasted factor as well. So on the dimension tool, what we want to show you, just a few more breaks, and especially on that radial dimension. And we're just going to see as we drag it dynamically, you're going to see how it adjusts the break, going over the lines and over the text. The past will only break over dimension lines, not over text. It's all about clear communication. Let's quickly add a geometric tolerance in here. We're going to build it up from scratch. Okay, Leon is going to add some datums, but that first range field there, in the past you could only put in values, numeric values. Now I can add text in there as well. So he's putting in a value called T, and then he's building up some datums, and we want to add information. So rather than trying to specify the value of T in that box numerically, we're going to actually add a note, and we're going to say T equals. He's created that because he keeps on forgetting numbers. So he copies and pastes it in there. But you'll see on the plus sign, I can actually go and add custom text. And now, if I drag that geometric tolerance, that's one thing. Okay. So we had a few guys here saying, like, yeah, that's going to be cool. Okay. So, and if you want to change it, you double-click it, you're into the edit annotation environment for the geometric tolerance. So, nice, cool. Last thing quickly on drawings. I want to get to a game. Just ISO, so this will be linked to your drawing template. So we're going to our document properties, and for surface finish symbols, we're selecting the correct ISO standard for it to show in my symbol. Okay, so you're probably going to set up templates for different ISO standards. Make sure you've selected that, and then when you add surface finish to your part, it's going to be according to the correct standard. Nice things in drawings. We're excited about where this all is going. Let's jump over to rendering. There's a nice announcement. Quickly, who used PhotoView 360? Against your will? PhotoView 360? Okay. Are you using Visualize now? You love Visualize. Those of you that used PhotoView 360, what is your biggest complaint of Visualize? It's not inside of SolidWorks. You have to leave SolidWorks. Okay. Fortunately, but it is good software. Right. Leon, let's go into what's new. DSPBR for SolidWorks Advanced Appearances and compatibility inside of SolidWorks, and it's compatible immediately in Visualize. You can now render straight from SolidWorks like we did with PhotoView. So there's an add-in inside of SolidWorks, one click, you're going to render in your SolidWorks, we're going to do it for you and immediately create. And then Stellar Fast Mode. Stellar Fast Mode's been around, but only working for NVIDIA. It now supports the AMD GPUs as well, so now that is available for everybody. Let's go and have a look at applying those DSPBR appearances on this model. Can you see those silver pipes lying in that carrier next to it? So as this is drilling, it's adding another pipe, drilling further, adding another pipe, drilling further. Okay, so we're going to add some galvanized steel onto that to make it very realistic. And then there's the DSPBR environment where we can actually do the roughness mapping of it to make it super realistic. Okay, we're going to see the effect of that in Visualize. Okay, we're applying it in SolidWorks, and now we're going to render inside of SolidWorks using Visualize. So there's a render tab. So make sure that you add your render tab. Sorry, we're just going to create a different, select a different background that we loaded in SolidWorks. Go to render, make sure our Visualize is added in, set our settings. So go, done. That's a pretty amazing, quick render, and you can see the quality even of that DSPBR files there as well. So that's we rendered that now live, for you. That's not a picture. So you can come and do it yourself on Leon's PC afterwards. Okay, I'm used to getting tuned by customers, but getting tuned by Quinn here and telling me it's a picture. Stellar Fast Render. Sorry, I am rushing through it. I want to get to simulation as well. Stellar fast render, so this is in Visualize, as I'm adding components and changing settings, it's continuously rendering, and as I'm rotating it, it's actually rendering it. In the past, we would see it go grainy every time I do, and it solves, where now, if I do this, it actually renders instantaneously. So that was working for NVIDIA cards, not for the AMD cards. Now it works for that. You can basically see no graining as I change this picture, and it's automatically rendering it all the time. So I don't have to go and set up render, see what it looks like, reset up render. It's dynamically rendering it for you. So we're going to jump into simulation. I cannot, no, sorry, PDM. PDM is still there as well. So we have to show you PDM. Transfer ownership. And a lot of the PDM enhancements are often not for the users. Okay? It's for the administrators. So is there any administrators around you, PDM administrators? Okay. You are the guys that's going to love this. Okay. The rest of you guys don't care about it. You stuff up the files, they have to fix it. So revision information, it's nice in the contains and the where used button. You can now see the revision as a field as well. So that's cool. But then there's additional information that helps the guys at the back when they have to support you if there's issues, or your administrator as to where those files are saved in the archive. And then the embedded preview in the past, not all the step and Parasolid formats were recognized by the embedded eDrawings viewer, and I had to go and open these things in SOLIDWORKS to see them. And if it's somebody that don't have SOLIDWORKS, they can't see what the part looks like, so that's been enhanced. And then last thing, this is one of Leon's favorites, because he looks at a lot of your PDM setups, and then you see a lot of different workflows, and you tell him, one of them is the one I'm using. Okay, now you can archive the rest, and then he knows the actual one that you're using. Transfer ownership. So, Leon, before you start with that, the scenario we've got is we've got an engineer named Eric that created parts, he's done edits to it, and then maybe he's left the country, his machine was formatted, or his machine crashed, but he never, and the administrators, you're going to agree with me, the users, they save it, but they don't check it in. Okay? So I've got a copy in my local cache, but I don't commit it to the server. Only checking commits it to the server. He'll show you. He's like, ah. So that's what Eric done here. And then Eric left. Okay? We formatted the machine, that's gone. So, Leon, we can go. Now we've got Megan, that's the manager. So this is Eric doing the changes that he asked him to do, and you'll see saving it, he's happy, he packed up, and he left. Right. Megan now needs to go and look. She sees that those things are checked out on his machine. His machine is not accessible anymore. In the past, that would have been data lost. We would have do an undo checkout, and whatever changes he made was gone. Okay. Now, there's actually regular cache backups that's happening in the background, and then Megan can now go and take ownership of those checked out files and check them back in. That is not a free ticket for you guys not to check in your files. Let's look at the contains and the where use tab and the information that's added. So a lot of you use this in different environments, so I can click on the contains tab and I can see where it's used and what's contained in there. But in the past, I couldn't see what revision the part was actually in. So now I can see that as a field. But there's also ID hexadecimal. I don't look at the hexadecimal codes. That's the thing Pierre will look at when he's solving problems, as well as the archive server path. So that's information that's now available with those parts in that environment, and a lot of that can be used for troubleshooting when files are not found or whatever. Okay, so small things, but it makes it very useful. For you as user, the main thing is the revision that's now available to see of the different parts in that assembly. So this is the embedded preview that's been enhanced. So the later step versions and Parasolid versions will now be viewable with the embedded eDrawings viewer. So I don't have to go to SOLIDWORKS to go and open them and see what they actually look like. Small things, as I say, especially for users that don't have access to SOLIDWORKS, go and look at that. Imported parts and things like that. And then, as I say, Leon's favorite, archive workflows. So if I go into my administration tool and I look at my workflows, there's two, my default one and then a new one that I'm building. As soon as I retire this one, I can right-click on it, I can archive it. Okay? And if I want it back, I can just un-archive it. But it's just some good housekeeping that if you know otherwise, you start chasing your tail if you've got 10 workflows sitting there and you don't know what was used last. Okay. So a nice housekeeping tool, again, for the administrators. And it makes our life easier when we're assisting you. Okay. That's just some highlights on PDM. As I say, structural simulation. I really want to get to this before we go for lunch. With this Navigator mini drill machine of Vermeer, it's a very nice use case for me of simulation as well. We're going to look at analyzing that back skid that lifts up the machine. It needs to lift up the back, angle the machine. We'll get into that, but the enhancement is the distributed remote load on shell edges. We're going to show you what could be done in the past. So very nice improvement when I do validity checks. You're going to see when I run it, and if there's issue, there's a very nice enhancement there, just making life a lot easier. And then we want to show you specifically a new plot that's available of rotational displacement. We're going to jump into SOLIDWORKS. So we're just loading this back skid of the machine. We're going to put it in context for you while it is solving. I've specified a few. Let's look at the parts first in this. If you zoom in on those parts there, there's a lot of meshing options. So some of these parts have been meshed with shell meshes, some of them with solid meshes. We've got a beam in there as well. Just click on that beam, Leon. That's that member that connects this back skid to the machine. And using all these different meshes allow us to get high accuracy but improve the performance because there's different mesh types that suit different parts, thin wall parts, beams, and those kind of parts. Okay, so it's a mixed mesh model. Right, we've got 3 pins, so the pins doesn't actually exist in the model. We specify them, that's a function of simulation. It's always been there, or been there for a long time. Because the pin relays the load, the pin is normally the strongest part, but it relays the load onto the different parts. Okay, so we've got the main pin over there, and then we've got the pin that's at the back, and the hydraulic cylinder is actually attached to that, and that's where it's pushing down on that pin, transferring all the load onto those 2 flat plates of that whole skid. Okay, and that's the most important stress point that we want to see in the effect of this. There's just another pin, again, that's set up in this, just keeping that rotation stable. So fixtures, that's already set up in this model. So this is a model with basically the whole analysis set up already, and then we're just going to continue and solve it. Okay, so the fixture, we just fixed it from the bottom as immovable. So this thing is pushed down into the ground until the point that it won't give anymore, and that's when it starts lifting the machine, applying the pressure. And then there's some loads on the beam. They're all reaction forces because the beam is now, because of the hydraulic cylinder pushing down this foot into the ground, this beam is pushing back and lifting the machine. So that's a reaction force that's been specified. That's those 2 yellow dots that you see. So we want to add the force of the hydraulic cylinder. So you don't add the full cylinder. Typically, you specify something like that as a remote load onto your part. We're going to define that remote load from that coordinate system that exists. So Leon has added another load. He's picking the option remote load. is picking the coordinate system, which defines the center of mass for the hydraulic system, and then I can go and select faces where I want to transfer that load, where it engages on it. So in the past, I could select faces on shell elements. But the thing is, for a real-world scenario, I need to actually put that pin is going to transfer it on that edge of that shell. So that is now what's been added, that I can select the outer edge. There, Leon is just making sure it's picking the outer edge of that pin on the shell model of those thin plates, and that will give you the most accurate load transfer to analyze this part. Okay. Leon, I think that is set up. You can now run this. First thing it will do, it need to mesh this model. Oops, error. Come on, what did you do? Oh, there's something that we forgot. One of the parts we forgot to add the material to. This here tells us the part. I copy it from here. I paste it into my search function of my simulation study. It filters it. It finds the part. And I just go, oh, okay, make that carbon steel. Okay. Just in the past, it will tell you there's something wrong, there's a part without a material, and then you have to go and sit and look, and where is that part? And it can be a lot of components. Now, that where it tells you the part, you take that, put it in, takes you right to the actual part. Massive enhancement. So that's a validity check that it's doing before it's running your simulation. We're going to run this. This is not going to run for too long, but while it's calculating, we're just going to quickly look back at what is this actually doing. So there's our entire machine, and then we're going to see the back skid being lowered down with the hydraulic cylinder, pushing the machine up at that angle. It's anchoring it in the ground. And the forces is the center of gravity of the machine. That's one of the main forces. That thing weighs a few tons, as well as the reaction force as it's drilling into the ground at a slight angle. It's pushing backwards as well. So it wants to move the machine backwards. So those are the forces that I need to compensate for when I analyze my part at the back. And that remote load basically comes through my hydraulic system. So I'm not using the entire machine and a massive assembly to analyze it. I'm taking that knowledge of the forces, the weight of the machine, and I know the force that this is going to push back at through testing, and I'm applying that as the remote load. I forgot the remote load you added was 120,000 newtons. Okay. When he added that load. So the fixtures, where we fixed the bottom of that skid, and then obviously the front of the track. That's where it's immovable on the ground. Okay. So that's all replicated in that small subassembly. Okay. It just shows us the subassembly. The next one actually shows it better. That's all the different forces that's generated in the whole operation of the whole machine, the weight and everything, is transferred through that beam and through that hydraulic jack. Okay. That's what we set up when we set up that simulation. Okay. What we want to do is we want to minimize the displacement for the stability during the operation. But also one of the things is we want to make sure that there is no rotational forces. Okay. Because that will start warping the system, can bend members and all those kind of things. Should be done. We return to SOLIDWORKS. Okay. It's done. Let's just look at the displacement plot. We can animate that. Very aggressive animation that we can slow down a little bit, calm down. Okay, so what we want to show you now, that's the normal displacement, but we want to see the rotational force. So we're going to add a new plot, and this is the thing that's also together with the selection of the shell edges in 2026. In 2026, I can also now go and add a rotational plot, the rotational displacement in a specific axis that I want to measure. We want to do, is it the y-axis? We want to check the rotation around the y-axis of that coordinate system. I can either measure it in radians or degrees. I'm going to select degrees. And there's my plot. Okay, I can animate it again. Okay. there's some rotation. How do I interpret that? Just if you zoom in on the actual plot legend, you'll see that the maximum rotational displacement is about 2 degrees of rotation it's causing. And that is starting with our knowledge to actually become dangerous. Okay, so we need to go and do a design change and stiffen up the member and things like that, or the plates on the side. So, okay, that's more of the same. We'll do an in-depth, focused session just on the simulation enhancements in different formats and share that information with you. I think it's very focused on the guys that's using it as well. So that's going to be us for what's new, what we're going to show you.